So, good morning to all. I am going to start now today
Good morning,
class.
sir.
Yeah, very good morning, Nana. I'm going to start. Just finish. Yeah, good morning to all. Yeah, thank you. Let me share the file. Yeah, great. Yeah, great. Welcome to last unit, superconductivity, which is really interesting and right. Okay. I hope you completed the attendance. So let me go for the. Yeah, we have discussed the superconductivity. So what are the superconductor? We know that superconductor are the conductor which basically shows the zero resistivity, zero resistance, and below a transition temperature. And most of the superconductors are made from the diamagnetic materials, ceramic, metals, uh, and they act like a superconductor at low temperature. The first who discovered superconductivity is Cameron Horns in 1911, and it was really big discovery for the all the sciences. And the next, Bones also discovered, finally he used the mercury and observed that. Uh, Give me 1 second. Observe that. Hello, I'm in the class, sir. Can I give you a call back later? Yeah, thank you, sir. So he was kind of very much passionate about the superconductivity, and he took that material, what material to mercury, and observed that at 4.2 completely its resistance becomes zero. So that is mercury act like superconductor at 4.2 temperature, and this is what he observed the graph. He plotted the graph between the resistance versus temperature, and finally its resistivity dropped zero at 4.2. And their general property that we discussed yesterday is also sometimes important for the four mouse and long answer. The general properties are electrical resistance of the superconductor is zero, right? And superconductivity does not change of the material when you add the impurities, but it changes its transition temperature. And also, superconductivity also does not affect its behavior, but if pressure and stress can change the transition temperature. And there is another property of the superconductivity isotope effect. The transition temperature of the transition temperature of the material is inversely proportional to the uh, mass, isotopic mass, square root of the isotopic mass. And also there is another property we discussed, magnetic field effect. When you apply the high magnetic field, its superconductive behavior changes into normal conductor. Okay, this is the really wonderful properties that we discussed as today. And coming to the very important property for the long answer, they are asking and define the Misner effect and classify the type 1, type 2 semiconductor. And these pictures are very helpful to understand what is going on. Okay, so let me try to explain. Sorry. So, what is the Misner effect? What is the Misner effect? So, Misner effect is the effect. Come on. So, Misner effect actually you can see here. There are two graphs. There are two maps here. This is a superconductor. This is a conductor. Let's say this is the some superconducting material. Is it clear? So here, I mean, in both cases, these two are the superconductors. So what is the difference here and here? At a particular temperature, this is a T greater than Tc, greater than a Tc what? Tc is a transition temperature. అంటే ఏ టెంపరేచర్ దగ్గర అయితే నార్మల్ కండక్టర్ సూపర్ కండక్టర్ గా బిహేవ్ అవుతుందో, ట్రాన్సిషన్ టెంపరేచర్ is the temperature at which the normal conductor behaves like a superconductor, right? And in this case, above the transition temperature, it behaves like a normal temperature. All magnetic field lines go through the sample. In case of other case, T less than the transition temperature, which means the temperature is less than the transition temperature now. The temperature should be, we are keeping the lowering the, as you all know that at low temperature only, please admin them, you can add them. I gave the permission to you guys, host. You guys are watching, sir. Immediately you can add them. Are you there? I gave the admin to some people. Nitish, I don't know what they are doing. Prashant, you should add them. Okay.
Okay, sir. Okay, sir.
Yeah, less than transition temperature means you are going down. You are going down. So this is higher than the transition temperature. Greater than the transition temperature, you can see this kind of picture. Less than the transition temperature, lower అంటే తక్కువ టెంపరేచర్ దగ్గర ఏమవుతుందంటే ఇమ్మీడియట్ గా నార్మల్ కండక్టర్ బిహేవ్స్ లైక్ ఎ సూపర్ కండక్టర్, అండ్ యూ కెన్ సీ field lines they do not penetrate into the sample. And the field lines, they don't go through the sample, they repel, they don't, the material does not allow the field lines through pass through it. Okay, and this is called Meissner effect. See, the complete expulsion of all magnetic field by superconducting material is called Meissner effect. Everybody should keep in the brain till you don't forget this. I'm trying to explain with the help of diagrams. Greater than the transition, important long answer. The greater than the transition temperature, greater than the transition temperature, the material, the superconducting material act like a normal conductor. Okay, less than the transition temperature, when you are lowering the transition temperature, the magnetic field lines completely expulsion, means expel, completely expulsion of the magnetic field by the superconducting material is called Meissner effect. Did you note down? Meissner effect is the effect in which superconducting material expel the magnetic field. The field line should not enter into the material, is called Meissner effect. Meissner is a scientist name. So very important thing, these two. Greater than the transition temperature, they act like a normal conductor. Less than the transition temperature, they act like a superconductor. What happens as superconductor? The field lines complete expulsion of all magnetic field by the superconducting material is called Meissner effect. So you can see the first point, the first bullet point, normal state is greater than the transition temperature. Superconducting state is the less than transition temperature. The Meissner effect is the distinct characteristics of superconducting from the normal perfect conductor to the. In addition to this effect exhibited by the superconducting is what happened? It's completely, there is a critical temperature also there. So less than the critical temperature also, it act like a superconductor, and we're going to discuss this. TC, HC, critical field, critical temperature. Below the critical temperature, below the critical field, the superconducting material behaves like a superconductor. Above the critical temperature, above the critical field, the material act like a Normal conductor. Okay. Is it clear? Is it clear, Meissner effect, all of you? Please tell me.
Yes, sir.
Yes, sir.
So normal conductor, this is, right? This is a superconductor. The difference is only, what is this? Temperature, right? Greater than the transition temperature, they act like a normal conductor. Less than the transition temperature, they act like a superconductor. What happens in superconductor? Magnetic field completely expulsion of all magnetic field by the superconducting material is called Meissner effect. And these are the properties you should know, that normal state condition, superconductor stage, okay, Meissner effect. I'm clearing now. I hope you understand.
Sir.
And you have to copy all the notes. Important factor to define a superconducting state. What are the important factors to decide whether the superconductor state or not? So critical temperature, critical field, critical current density. These three factors are very important. Even these are very important points for the competitive exams for the master or PhD degrees. What are the important factors, beta? Critical temperature, critical field, critical current density. Less than the critical temperature, it acts like a superconductor. Less than the critical field, it acts like a superconductor. Less than the critical JC, it acts like a superconductor. So what is here? You can see here. This is a critical field. This is a critical current density. This is a critical temperature. If I draw X, Y, Z axis this, you're going to get this kind of shape. Critical current density, critical field, critical transition temperature. So you should know that. And coming to the very important examples. What are the examples and their critical temperatures? So critical temperature of some material is posted here. The temperature at which, what is the critical temperature definition I told you? Critical temperature is the temperature at which normal conductor transform into superconductor. నార్మల్ కండక్టర్ ఏమవుతుంది సూపర్ కండక్టర్ గా మారిపోతుంది టెంపరేచర్ ఎట్ విచ్ ద మెటీరియల్ ఎలక్ట్రికల్ రెసిస్టివిటీ డ్రాప్ సడన్లీ టు జీరో వాల్యూ is called critical temperature or transition temperature. So when the material moving from normal to superconductor, what is the fundamental property? Resistivity is zero. Resistance is zero. Suddenly drops. Suddenly drops it. Resistivity versus temperature. This is a TC. Suddenly drops its resistivity zero. So temperature, critical temperature, transition temperature definition, we know that now. Temperature at which the material electrical resistivity drops to the zero. Below critical temperature, material is said to be superconductor. This మొత్తం కూడా superconductor. Above this, normal conductor. Below this temperature, superconductor exhibits variety of several outstanding, like many important properties. So I'm going to close this. So what is the importance of critical temperature or transition temperature of the superconductors? Simply, sir, we know the three properties, sir. Transition temperature is the temperature at which normal conductor transforms to superconducting state, and at that point its resistivity drop to zero, and below transition temperature, sir, it behaves like a superconductor. Above transition temperature, sir, it acts like a normal temperature. Now we got it. You guys are smart, really scientists, great scientists. So aluminium transition temperature is 1.2, tin or 3.7, mercury 4.2. These are the MSc competitive exam questions. Okay, you should take and remember those values. More important, mercury, because This is discovered by the Camerlin ones. Okay, then moving into very important graph, and they will ask, actually if they ask long answer, explain the what is the superconductivity, explain the general properties. General properties means you can explain all those properties that we discussed, and you can also explain the transition temperature, explain with long this graph and everything, then you get full marks, 12 marks. So electrical resistivity versus temperature plot for a superconductors and normal conductors. So you can see this graph. So what is this graph here? This is a temperature versus resistivity graph. We already discussed this, right? From this figure, you can see superconductor, normal metal. So what is the difference here? Tell me. Superconductor, it comes like this, suddenly drops to 0. Resistance equal to 0. But normal metal does not. So there should be condition in the super conducting materials తీసుకోవాలి. So diamagnetic materials are the best material to consider the superconductor. So metals cow, normal metal, they are not a superconductors. So normal metal, they don't act like a superconductors. So normal metal graph ila untundi, superconductor graph ila untundi. Did you remember this graph now? Did you keep in the brain chip? Brain lo pettukunnara? Difference between the normal metals and superconducting metal graph. గుర్తుంచుకున్నారా? Hello my dear students.
Yes, sir.
Yes, sir.
So నార్మల్ కండక్టర్ డ్రాప్ ఇలా ఉంటుందని బ్రెయిన్లో పెట్టుకోవాలి. సూపర్ కండక్టర్ డ్రాప్ సడన్గా డ్రాప్ అవుతుంది. సో మరి డయామాగ్నెటిక్ మెటీరియల్స్ని యూజ్ చేసినప్పుడు మాత్రమే మనకి ఇలా వస్తుంది. సో దే ఆర్ ద బెస్ట్ మెటీరియల్ ఫర్ ద సూపర్ కండక్టింగ్ మెటీరియల్. ఓన్లీ మెటల్స్ కాపర్ అవి తీసుకుంటే యూ కెనాట్ సీ ద సూపర్ దే ఆర్ కండక్టర్ బట్ దే డోంట్ బికమ్ ఏ సూపర్ కండక్టర్స్. ఓకే, అండ్ from the figure it can be seen that electrical resistivity of normal metal decreases steadily as the temperature decreases. So it is decreasing steadily but reaches a low value at 0K. But superconductor suddenly it becomes 0. That's what you have to remember it. And this graph also very important, beta. This graph also very important. The question they will ask, I'll show you question how they are asked. So we have already discussed critical temperature. Now the critical field. We discussed the critical temperature. Before graph enti critical temperature laga pettam. So it's a before graph is actually resistance, temperature versus resistance. We got like this, right? So this is a superconducting. This is a superconducting state. This is normal conducting state. Here, critical field HC also come into play. Here only this is TC. Here external magnetic field B versus T. BT graph. What happened? Your external field you are applying, right? And when you apply the high field, what happened? It becomes normal conductor, right? As you increase the field, what happened? It becomes normal conductor. When you apply the external field to the superconducting material, it becomes non-superconducting. And this is the minimum magnetic field required to destroy the superconducting state is called critical magnetic field. If I ask you what is the critical field, Nana, ante sir ఆ ఫీల్డ్ దగ్గర మొత్తం కూడా సూపర్ కండక్టింగ్ స్టేట్ లో డ్యామేజ్ అవ్వడానికి మనము అప్లై చేస్తున్నాం. అందులో డ్యామేజ్ మొత్తం అయిపోయి అది నార్మల్ కండక్టర్ లాగా బిహేవ్ అవుతుంది. సో క్రిటికల్ ఫీల్డ్ ఇస్ ద ఫీల్డ్ వేర్ the entire superconducting material completely destroys, and that is actually critical magnetic field. Critical transition temperature is the temperature at which Normal conductor become a superconductor. A transition temperature దగ్గర సడన్ గా రెసిస్టివిటీ జీరో అయ్యేదేమో అది critical temperature. Critical temperature is temperature at which the material's resistivity drops to zero. But here, critical field is the field at which the field required to destroy the superconducting state is called critical field. ఆ ఫీల్డ్ దగ్గర మొత్తం సూపర్ కండక్టివ్ స్టేట్ అనేది నార్మల్ కండక్టర్గా వచ్చేస్తుంది. సో గ్రాఫ్ ఇలా వస్తుంది. దిస్ ఈజ్ ద సూపర్ కండక్టర్, ఇట్ సైడ్ మొత్తం నార్మల్ కండక్టర్. టీసీ ఫిక్స్ చేసాము, ఫీల్డ్ యు ఆర్ ఇంక్రీజింగ్ లైక్ దిస్. ఓకే, ఎట్ పర్టికులర్ ఫీల్డ్ కంప్లీట్లీ ఎట్ కంప్లీట్లీ వాట్ హ్యాపెన్, సూపర్ కండక్టర్ బికమ్ ఏ నార్మల్ కండక్టర్ లాగా అయిపోతుంది. So this graph also you have to remember it. Very important graph. And the equation for that is this one. So what is the equation? So HC is equal to, HC is a critical field, is equal to H naught is the applied field, 1 minus T by TC whole square beta bracket. You should remember this equation. HC is equal to H naught whole square bracket 1 minus T by TC whole square. So here you can remember beta what is going on. If I keep T equal to TC, what happened, tell me? This TC cancel, 1 minus 1 0, right? 1 minus 1 0. So HC 0 అయిపోతుంది. So you should be balance this. HC is equal to H naught 1 minus TC by T by TC. So T should not equal to TC always. It should be, what happened? It should be less than TC only superconductor. T greater than TC is normal conductor. See, this is T greater than TC, normal conductor, right? So this entire thing is normal conductor, less than is superconductor. I hope you understand, right? Can I clear it?
Yes, sir.
Yeah, thank you. But the strength is very bad. Long answer, but they don't have. This is also wrong answer. Like 50% of the long answer. They'll adding actually this one and the previous ones. Type 1, type 2. Differences between the type 1 and type 2 superconductor. 6 marks for this. So what are the differences between the type 1 and type 2 superconductors? And the very, very important bit actually. So type 1 is pure, completely pure superconductor. Type 2 is mixed superconductor and normal conductor. Okay. So soft superconductors are those which can tolerate impurities without affecting the superconducting properties. సో టైప్ 1లో కంప్లీట్గా మన గ్రాఫ్ ఎలా వస్తుందంటే ఇలా వస్తుంది, ఆర్ ఇందాక వచ్చింది కదా ఇలాగనే వస్తుంది, కరెక్ట్గా డ్రాప్ అవుతుంది. ఏది టీసీ దగ్గర కంప్లీట్ సడన్ డ్రాప్ ఉంటుంది. ఇదేమో బీటీ గ్రాఫ్, ఇది కంప్లీట్ డ్రాప్ అవుతుంది. వేరేస్ టైప్ 2లో ఇది కంప్లీట్ ఇలా డ్రాప్ అవ్వదు, ఇలా వెళ్తుంది, కరువు ఇలాగా వస్తుంది, డిఫరెంట్గా వస్తుంది, సడన్ డ్రాప్ ఉండదు. ఓకే, సో సాఫ్ట్ సూపర్ కండక్టర్ ఇంపార్టెంట్ బిట్ ఆర్ దోస్ విచ్ కెన్ రైట్ డౌన్, which can, or maybe screenshot take and copy later. Soft superconductor are those material which can tolerate impurities without affecting the superconducting problem. Ante we can add the impurities to change the TC only. Ante kada manam impurity chesedi, they don't change nothing. So to reduce TC or increase TC, we add the impurities. Hard superconductors are those materials which cannot tolerate impurities. The impurities affect the superconducting property. So in a hard superconductors, when you add the impurities, they change the superconducting property. In soft superconductor, they do not affect the superconducting properties. Very easy bit, right? Type 1 lo emotundi, soft superconductors basically they basically which do not, the impurities should not affect the superconducting properties, whereas the hard superconductors in which impurities affect the superconducting properties. So they cannot tolerate. Also called soft superconductor. We also call soft superconductor. Here hard superconductors. Okay. Here only one critical field exists. Only HC ఉంటుంది అంతే. సడన్ గా ఇలా ఒక్కటే ఉంటుంది. Sudden HC. Okay. So whereas here two critical fields are there, HC1, HC2. అంటే ఇలా క్రాసింగ్ ఉంటుంది. HC1, H2, HC2. There are two fields exist at which resistance equal to 0. Suddenly drop over 0. So only one critical field is here. Here there are two critical fields are there. Critical field value is very low because this is the critical field one, very low. Here critical field is very high. It exhibits perfect complete Meissner effect. Meissner effect complete ga ila complete ga ila expel avutadi lines. But here they don't exhibit perfect complete Meissner effect. They do here, they do go through the sample. Some of them they expel it, some of them they go through the sample. So you cannot see the Meissner effect perfectly in the type 2. The current flow through the surface only. Here completely current flowing through the sample only surface. Here the current flow that current throughout the material inside kuda eltadu, lopal kuda ellipotundi. So the materials are limited technical applications because the very low field. So the applications are very limited only because of the very low fields it applies. And these materials have wider technology applications. Sorry. Here there are a lot of applications because here composite material we use it, very high field, so we can use a lot of applications. So I think is it clear, please? Don't
Yes,
say I
sir.
know, I understand everything. I know you didn't understand. Right? Can we summarize this because it's a very important question. What are the difference between type 1 type 2, Nana? First difference is what? It's of course it's what is it type 1? The impurities do not affect the superconducting properties. Here impurities change the superconducting properties. That's the first point. We call it soft superconductors. Here we call it hard superconductors. Here only one critical field exists. Here two critical field exists. Critical field is very less. Critical field is very high. This exhibit Meissner effect completely. Here it doesn't. It doesn't. We can't expect a complete Meissner effect here. Current flow through the surface only here entire material. And the applications are limited because low field. Here applications are very high. So now I'm closing. I want you to tell all the points. Can you keep in the brain now? Close your eyes and keep in the brain. The first point, impurities do not influence on the superconducting property. Here they influence on the superconducting property. The second point is soft superconducting, hard fluid. It has only one single critical field there, two critical fields. Here exhibit completely Meissner effect. There it doesn't exhibit. The current flow through only surface. Here it should through the material. Here the material have a limited application because of the low field. Here high field. So I think you guys clear it. I hope you understand it. And I'm going to ask now to practice this question. And this is the another last point to enter it. Type 1 superconductor ఒకటే SC ఉంటుందని చెప్పాను కదా, only one single SC. This diagram also important. Here it's kind of penetrating HC1, HC2. Immediately suddenly zero అవ్వట్లేదు చూడండి. Suddenly it's not equal to zero. It's completely superconducting. But here mixed normal conducting state there, superconducting state. This is a mixed. Type 2 superconductor mixed state. Here single state. And this is also important to draw. Should able to draw it. Okay. Then practice it now. I'm going to ask now. Low TC superconductor, high TC superconductor. We're gonna discuss. Some videos are there. I'm going to. I'm going to explain tomorrow this last class. I mean, not last class. Superconductor last. So tell me now. Tell me now. What's the time now? Still we have time, right? What's the time? Oh, 10 o'clock only, right? Still we have a time. We can complete it. We can complete it. But I want to show some videos are there. Okay. What happens, students? Completely they are, I'm going to post, why they left. Can you take the print screenshot and post it to me? I'm going to give only attendance for these 13 students. I don't know why they are, exiting. It's very bad. You don't have minimum common sense, guys. Right. So anyway, so can anyone summarize this type 1 and type 2 superconductors now, please? I'm going to ask Ibrahim Patan student. Yadgiri, తెలుగులోనే చెప్పిన పర్వాలేదు బేట. I think you just tell whatever you understand. Yadgiri,
Sir, good morning, sir.
good morning నాన్న. చెప్పు నాన్న, నీకు అర్థమైన కాడికి చెప్పు. టైప్ 1, టైప్ 2.
Sir,
టైప్
type
1
1 లో సాఫ్ట్ కండక్ట్ ఉంటుంది సార్.
ఓకే.
సాఫ్ట్ కండక్ట్ ఉంటుంది. టైప్ 2 లో హార్డ్ కండక్ట్ ఉంటుంది.
హార్డ్ సూపర్ కండక్టర్స్ అంటారు, ఎందుకంటే అవి ఇంప్యూరిటీస్ యాడ్ చేసినా కూడా అవి చేంజ్ అవుతుంది ప్రాపర్టీ. సాఫ్ట్ సూపర్ కండక్టర్స్ అని మూడు వాడాలి. సాఫ్ట్ సూపర్ కండక్టర్స్లో మనకి ఏమవుతుందంటే ఇంప్యూరిటీస్ అవి ఎఫెక్ట్ చేయవు. థర్డ్ పాయింట్ పెట్ట నెక్స్ట్.
ఓన్లీ వన్ ఉంటుంది సార్ ఇందులో.
ఓకే, వన్ ఏంటి మ్యాగ్నెటిక్ ఫీల్డ్, వన్ క్రిటికల్ ఫీల్డ్ మాత్రమే ఉంటుంది దాంట్లో.
ఇందులో 2 క్రిటికల్ మ్యాగ్నెటిక్ ఫీల్డ్.
ఇందులో మెజనర్ ఎఫెక్ట్ కంప్లీట్గా సాటిస్ఫై అవుతుంది, దాంట్లో అవ్వదు.
సార్
అంతేనా?
సార్.
ఇంకా
ఫోర్త్ పాయింట్ వచ్చి వెరీ లో సార్. ఇది
ఇట్స్ వెరీ మ్యాగ్నెటిక్ ఫీల్డ్ లోగా ఉంటుంది కాబట్టి అందులో ఎక్కువ ఉంటుంది, కాబట్టి అప్లికేషన్ ఎక్కువ ఉంటాయి. దీంట్లో తక్కువ ఉంటుంది కాబట్టి అప్లికేషన్స్ తక్కువ, అంతే కదా?
సార్.
ఆ గ్రాఫ్ ఒకటి గీయాల, కరెక్ట్గా హెచ్సి ఒకటి ఉంటుంది, దానికి ఏమో రెండు ఉంటాయి.
సార్.
సుష్మా ఇప్పుడు చెప్తుంది. సుష్మానా స్వప్న ఉందా? సుష్మా, కెన్ యూ టెల్?
Yes, sir.
Yeah, please.
In soft superconductors, they doesn't affect the impurities add చేసినప్పుడు అది ఎఫెక్ట్ కాదు సార్.
They don't influence the superconductivity. Okay.
In hard superconductors, it affects the impurity,
right?
superconductivity property.
Okay. Then
in type 1, it has only one critical field.
Okay.
In type 2, two critical fields ఉంటాయి.
Okay.
In critical field value, in type 1 very low.
Okay.
In type 2 high.
Okay.
In type 1 it exhibits Missionary effect. Missionary effect.
Okay.
In type 2 it doesn't exhibit the Missionary effect.
Oh, okay. Good. Very good.
In type 1 current flows through the electric
Okay.
surface.
Okay.
In type 2 it doesn't, it flows through the particle.
Okay. Very good. Very good, Shma. Yeah, I don't know others today. I cannot see anyone. Girls are very less. Gautami is there. Sushma there. That's it. Swapna, everybody absent. I'm keeping absence. Okay. And very bad. I'm not going to give any practical marks. Those who are regular, definitely they'll get good marks. I mean, very bad. I mean, they don't understand. I've been trying to explain it. Okay, anyway. So my job is to complete syllabus within a couple of classes. I don't want to, waste my time I'll just finish, a few more things. Very good, Sushma and Yadgiri, uh, for sharing your.
Thank you, sir.
Thank you, sir. Thank you.
Very nice, very good, very good. Thank you. So yeah, let me go further. Few more things. I already completed this. Yeah, there is a really, it's really great research now. If you feel it, you feel like the great research is going on superconductor. I know one of my classmates, one of my friend is doing this research in IIT Hyderabad. I mean, if you really passionate, I can send you there also to get some experience. But you should have some passion, not like a time pass. Okay. Anyway, this is a really good field to work research. I mean, there are two types of superconductor again. I mean, type 1, type 2 are there really, but this is a kind of low TC superconductor, high TC superconductors. So what are the low TC? I mean, they behave like a superconductor at a low transition temperature. That is the reason we call it as a low TC temperature superconductor. I mean, the material which behaves like a superconductor at a higher transition temperature. The only difference is transition temperature is higher for this superconductor, here transition temperature is lower. The superconductors that require a liquid helium coolant are called low temperature superconductor. The superconductor that require liquid helium coolants are called low TC superconductor. Liquid helium already we studied 4.2 transition temperature and at which resistivity is 0. And superconductor having the higher TC value, okay, above the transition temperature, liquid helium temperature, like a 77 K liquid nitrogen. 77 K is liquid nitrogen temperature, liquid helium temperature 4.2. So low TC superconductor is about a 4.2 temperature, transition temperature. High TC superconductor transition temperature is about like a 77. At this temperature, they behave like a high ITC superconductors. That's the only 4 marks question. Sometimes they also mix A, B, C, D in the long answer question. So now it's clear what is the low TC and what is the high TC. Low TC superconductor always the 4.2 Kelvin. High TC superconductor always the transition temperature is about liquid nitrogen. And the important bits also completed exam. What are the low TC? What is the low TC temperature for the superconductors? What is the temperature at which we call it low TC superconductor? 4.2 liquid helium. High TC superconductors ekkada ante liquid nitrogen temperature which is 77. Magnetic levitation. Wow, this is the applications. The two very important applications with a magnetic levitation, which is actually flying in the air. I told you yesterday, magnetic levitation. Magnetic levitation, I'm going to show that video also in next class. Magnetic levitation or maglev or magnetic suspension is a method which object is suspended with no support other than the magnetic field. There is no support you can see here. Other than the magnetic force is used to counteract the effect of the gravitational and any other acceleration. So what is going on here is it repel. This is superconducting material and this is magnetic material. You know that at a particular critical field or particular transition temperature, the field line should not pass through the material. They pass through Meissner effect, right? So they go like this. So they don't go inside the material. So this is the reason they just fly out of this material. So this is kind of like very interesting phenomenon. We are using this application in the bullet trains to make the bullet train. The two primary issues involve the magnetic levitation, lifting force, providing the upward force sufficient to counteract, counteract gravity. Gravity can ఎక్కువ మనము provide చేయాలా, and stability. And these two things are very important things. to have this magnetic levitation. Okay, stability ensuring that system does not spontaneously slide or flip into the ఇది ఒకవేళ ఫ్లిప్ అయింది అనుకో మనకు బుల్లెట్ ట్రైన్ కింద పడిపోతుంది. సో ఇట్ షుడ్ నాట్ సపోజ్ టు ఫ్లిప్ ఇట్. So that's what you have to understand. So magnetic levitation is one of the wonderful property to use in the bullet train applications. So here what Misner effect play very important role, and the two things are going on: lifting the force and stability. These two are the important points to remember. So I mean I'm going to show again this tomorrow. I think it's over. A lot of bullet train applications are there, I mean, you already saw yesterday some applications, trains like, pulling the waste, magnetic material from the waste. Josephson effect, this is the last, you don't need, I think, you don't have these superconductors. Josephson effect. I'm going to tell tomorrow class, don't worry. Applications, I already told that. NMR, okay, thank you. So tomorrow we'll discuss kind of some applications. Then I'll close tomorrow this superconductors. So tomorrow class is the last class for the superconductors. So one question, long answer, 4 months is already over. The baby, whatever we did it, just this they ask question. I think in the recent exam also they asked type 1, type 2 Misner effect long answer. Okay, and they ask some problem also, like HC equal HC into 1 minus T by TC. That will be the problem again, 4 marks. So they give the TC value, they give the T value, they give the H naught value. So H naught into 1 minus TC by T by TC whole square. So that is also important formula. Okay. So thank you so much. Have a wonderful day. You can have the 3 to 4 minutes break for the next class, which is Tirumala Desai going to, I think he's also dealing with the last chapter. Okay, thank you, Nana. And
Thank you,
do well,
sir.
and do well. All the best for the exams. Balance all the time, like semester exams and the classes, but don't skip the classes for the exams. These are also very important. Immediately you have these exams too. So, okay,
Okay, sir. Thank you.
right. Thank you, Ibrahim Patna students too.